Hello and welcome to this introduction to fractals. This presentation will look at the basic properties of fractals, provide a brief historical timeline on the development of fractal geometry, look at the different types of fractals, and finally describe a few applications. So let's get started. So what is a fractal? Well, fractals have two basic properties. They are self-similar and have a non-integer dimension. So what does that mean? Self-similarity is found in a geometric shape or object that has smaller copies of itself as you zoom in closer to the shape or object. This is the Mandelbrot fractal, one of the most famous fractals out there. This smaller image is a zoomed-in copy of this portion here in the red rectangle of the whole fractal. Notice that it looks like a smaller copy of the original fractal. This is what is meant by self-similarity, and with fractals, you'll see this on an infinite scale, or with natural fractals until replication stops. Self-similarity can be exact or statistically similar. For instance, this tree is self-similar. The tree trunk branches off into smaller versions of itself. But these smaller branches are not exact copies of the tree trunk, but they are similar. So what do we mean by a non-integer dimension? Well, we're familiar with 1, 2, and 3-dimensional objects. These are dots, lines, cubes. Fractals have dimensions in between these whole numbers. For example, a mountain is not three-dimensional like a cube. It has no smooth surfaces or straight edges. But it's not flat like a line either. It exists between 2 and 3 dimensions. This timeline shows an overview of the development of fractal geometry. As you can see, it started in the late 1800s. But wasn't formally defined until 1967 by Benoit Mandelbrot. Mandelbrot published his famous How Long is the Coastline of Britain paper that described fractals and their unique properties. He was able to piece together the work of those previous mathematicians to make this new discovery. For this, he is often called the father of fractal geometry. There are several different types of fractals. This is the Mandelbrot set. In his research, Mandelbrot used a computer program to generate a graph of a complex function over and over again. He found that the result constructed these amazing images. Through that same technology, it was possible to graph the Julia set that Gaston Julia had discovered back in 1918. But there was no technology at that time that allowed him to graph the Julia set. IFS, which stands for Iterated Function System, is another type of fractal. This is a random IFS fractal. Here we have an example of an IFS fractal flame. The Koch snowflake, based on the Koch curve, is a base motif type of IFS fractal. You start with a base and replace the base with the motif. So for the snowflake, you start with a triangle as your base. Then you replace each side of the triangle with the Koch motif. You continue to do this as shown in these images. Finally, there are natural fractals. Our world is filled with naturally occurring fractals, from the smallest neuron in our brain to the patterns in the galaxy, and so many things in between. Fractals have a purpose. There are many different applications in the world for fractals. Fractals are found in the physiological makeup of our bodies, our respiratory system, blood vessels, even our brain activity. Fractals can be used to represent irregular shapes, such as coastlines, snowflakes, trees, and rivers. Fractals can be turned into beautiful art and are used in computer programs that generate realistic images of landscapes, textures, and movement. The first use of fractals for movies was for Star Trek II: The Wrath of Khan to create an alien landscape. Technology has also benefited from fractals. This is the Sierpinski square, which has been used as an antenna in a cell phone to maximize data reception. That concludes this introduction to fractals. Thank you for watching, and I hope you continue to discover the incredible world of fractals.